page here, I gave you purposely all odd numbers because you don't mind the double angles, right? Double angles are cos of 6x. You love these ones. These ones are double angles. And you go, oh, okay, so I know that that is the same thing as cos of 2 3x's. Yeah, we got that. 2 3x's. We know my angles, 3x. Even numbers, for some reason, everyone loves, right? So it works with odd numbers as well. So this here, so I'll just write that up here. So cos of 6x, we love these ones, is cos of 2 3x's, right? So 3x's, we're good at breaking up even numbers. So even numbers there, but it works with odd numbers as well. And you just don't like these as much. So that's why we're going to practice it 3 times on this page, right? Let's get used to it. So this is also a double angle. It's double 2.5. It's double a 2. Everything can be halved, right? Everything's a double angle. It doesn't have to be even. It's a double angle of the 2.5 angle. We don't tend to like decimals, though technically it's the same thing. So we tend to go like this. Use the double angle formula to rewrite the ratio. And you go, can't. It's odd. That's not true. So it works for odd. So works for odd numbers 2. Right? That just seems to be a block for people. They're like, but it's not double. It is. It's double 2.5. But we're not going to go into the decimals. We're going to use fractions. So keep it in fractions. So keep fraction. Okay, not decimals, please. And then so here, we're going to just rewrite it. And we're going to say this is the same thing as cos 2. And so look, right? So that would be easy to do. If it's a 6, you go, it's double 3x's. Right? If it's a 2, it's 2 times the x. If it's a 4, it's 2 times 2x. You love the even number. What would it be if it's a 5x? It's double 2.5, but we're not going to go decimal. 5 over 2x. It's double that. So you can put the x on it. Okay, it's the same thing. You're just, and again, people go, oh, the decimal makes more sense, but we do tend to keep it in fractions for some reason. We just love fractions. It's just easier to work with in other formulas. Okay, so we like this. So it's double that. So it works with odd numbers even though. So what would this one be? And again, we still have more steps to do, but let me just set this up. So this would be sine of 2 times, and I know it's x, so it's double what? X over 2, half, 0.5. So again, that's just get over the fact that you want it to be an even number. It's not always an even number. It's still a double angle, right? 2 times 3.5, 2 times whatever it is. If it's 15, right? 12.5. You're allowed to be double anything. So there. Then they want you to rewrite the ratio, so keep going. So we want to keep going with this, using this to rewrite it. So this formula here, we have 3 choices, right? We're going to do all 3 choices just because there's only one more step to do. So there's 3 choices. So I'll do the first one. So the first one here, I'm going to use the cos squared minus sine squared one. So this will be cos squared of my new half angle, so 5x over 2, minus sine squared of my new 5x over 2, like that. That's one. Beautiful, gorgeous, love it. Can't get enough of it. There you go. Or let's do all 3 just because we have so much room here. Put too much room here. So, or for the second one, I always remembered that because it's the cos 2, it starts with cos. So the second one would be equals 2 cos squared, and then this half angle. So this will be 5x over 2, and it's minus 1. Right, I always remember cos goes first because it's the cos double angle. Or, right, and all 3 of these would be acceptable because it's not going any further. So any of the 3 would be okay. I would do, for the next one, would be 1 minus 2 sine squared, and then you still put this half angle in there. That's it. So all 3 of those are all good. Any of them are fine. Do the same thing for this one. So now you can see what my point is. All I was trying to get used to is that the angle doesn't have to be a whole number, right? You're thinking whole number, whole number, whole number, but it can be a fraction. So there's only one choice here. So this one has one choice. There's no other choice. There's one formula for this, which would be 2 sine, and it's x over 2, cos, and it's x over 2. There, that's it. Any questions with that? Yeah. Okay. All right. We just have one last example to do, and I'm doing the same thing. I chose an odd number. Again, I just need you to get used to it. Whenever I ask for theta, it's easy, right? 4, 6 is any of the even numbers, but it can be done with an odd number as well. This is the one that throws people off. So let's try it with an odd number, but I can do this with this question with any kind of combination. So let's read it together. It says, use the appropriate compound. Compound means addition, subtraction, right? So the addition, subtraction one, that's the compound, and double angle. Right? So, and double angle formulas to develop a formula for cos theta. It's missing some words, so either I badly worded it or the book did, so I don't remember what. It should say in terms of theta, right? It should say that. It's badly worded. It should say that in terms of theta, because otherwise you can never stop. You can make it the half angle, the quarter angle, keep going the eighth of an angle, the sixth. You keep halving your angles. It's a never-ending question. I can keep writing it and developing it until it becomes an infinitely small angle. So here, I want you to stop when you get to theta. So my goal is theta, so it should tell you where to stop. I realized afterwards, I was like, look, I teach you this, and it keeps dividing. You can keep dividing it. So I want you to stop when you get to theta. So this is important. Okay, I want you to stop when you get to theta. So I want you to write the cos of 3 theta and keep breaking it down until you get to theta. So break down this until you get to theta. Okay, so I don't want to go to fractions. So don't do 3 pi over 2 or 3 theta over 2. So no fractions. I want it to be in terms of theta. So this is specifically saying don't go to fractions. Okay, how do I do it then? If you're like, okay, wait, don't I always? No, I said you can use the compound or the double angle formula, or any combination. So if I said only double angle formula, you'd be like, you're crazy. I can't do it. Half of it is 3 theta over 2. I have to have a half. But I said you can also use compound. So compound means that you're going to take this guy here, cos of 3 theta, break that down using the compound versus the double angle. The double angle would force us to go to fractions. It would have to go 3 theta over 2. And I said that's okay. But in this question, I'm saying I want it in terms of theta. So then I would go and take this one and break it down to this 3 theta, not half fractions, but we're going to go theta plus 2 theta. There you go. So I'm breaking it up into 2. They don't have to be the same. Then I'll break down the 2 theta one more time afterwards, right? But then how do I break this down? I have 3 choices. So not fun marking this, because when I mark it, I have 3 sets of answers that I can look for. So this here, I have 3 choices. I'm not going to do all 3 this time, so choose one. So 3 choices. So choose 1. So which one do we want to do? The sine squared, cos squared, or, oh no, wait, sorry, not here. This is not 3 choices yet. This is only 1 choice. Sorry, wrong line. It's the next one when we get to the double angle. This is the cos, sine. Sorry, I jumped ahead. Oh no. There you go. Sorry, I jumped ahead. This one's there's only 1 choice. It's the cos, sine. So this one would be cos theta, cos 2 theta, minus sine theta, sine 2 theta, sorry. Now I have 2 choices, 3 choices. So this one's set, I'm done, this one, beautiful, gorgeous. This one I have to keep going, right? And then this one I have to keep going because I want it in terms of, right? I want theta. So keep going with these 2, stop on those 2. For this one, I have, that's the one I was saying, this one I have 3 choices. Which one do you choose? Any. I would have 3 sets of answers. So like what I did up here, I would accept all 3 of those answers are fine, right? So here I'm going to have, again, for this part here, that's my 3 choices. 3 choices. It's for this one. That one, there's only 1 choice, and here we go. So let's get our next step. So this would be cos of theta stays as is. This guy here, which one do you want to do? 2 cos squared minus 1 minus 2 sine squared, or cos squared minus sine squared? Choose. Formula 1, 2, or 3? 2. Okay, so that was 2 cos squared theta minus 1. And again, you have any choice, and all 3 would be fine, and I would have, when I'm marking, I look for any of the 3 answers are all equivalent. So this one here, I'm plugging that one in, so of my 3 choices, I chose that one. This stays sine theta, don't touch that one. This one, there's only 1 choice, right? There's only 1 choice. It has to be 2 sine theta cos theta. There's no choice in that one. Has to be, nothing to do. Then we're going to keep going, so get rid of brackets, so remove brackets, so no brackets. So no brackets, please. So we're going to do boom, boom, and then bring those together. Okay, so my answer, whenever I can simplify, I want you to simplify. Okay, so simplify as far as you can. Here, when I expand this guy out, I'm going to get 2 cos cubed, right? 2 cos cubed theta, right? 2 cos cubed theta minus cos theta, yes? Okay, and here I would get minus 2 sine times sine, so sine squared theta cos theta. Can I do any more? That's it, right?
Do you want us to factor it or not?
Common factor? Nah, because then we're going backwards and forwards. So here I said get rid of the brackets, just expand, simplify. Okay? And again, there are 3 different choices you can have, right? So if you had subbed in the cos squared minus sine squared, you have a slightly variation. If you do 1 minus 2 sine squared, you have a slightly different variation. They're all the same, just slight variations of it, right? So here I would have or. So 1, 2, 3 possible answers. And if you feel like, okay, we're not doing anything, we're trying to get you comfortable with the formula, manipulating it, breaking it apart, bringing it together, right? So it's just trying to get used to the formula. Good. Anything else? Any clarification? And we stop there. Yeah, so you don't have to factor it. Just stop there. Expand, collect, get rid of brackets. We're done.